Bruh. Welcome back. Oh, it's been a while. Yeah, sorry about that. I hoped we could go back to streaming like on Monday, last Monday, and in reality, no, that didn't work out. So I got COVID. It's always fun when that happens. Yeah, I went and I went to a concert. What was that? Last week, and I was all covered up and stuff, and I'm of course triple vaxxed and stuff like that, and yet I ended up getting COVID anyway. Luckily, it was a light form, so it was just the worst flu I've ever had. But I honestly couldn't do anything. I couldn't like sit in front of my computer for longer than 10 minutes, and I was coughing and everything else. It was pretty terrible. But at the end of the what was that? Yeah, I had to stay in self-isolation for 10 days from the beginning of the symptoms, which were last Sunday. Yeah, I basically tested positive on Monday, and then from then on I couldn't do anything. So I had to skip a few streams, which was less than ideal. Honestly, it would have already been fine the beginning of this week, but I didn't want to push it. I still have the occasional coughing fit sometimes, but mostly I'm fine now. I mean, the proper symptoms lasted for about like 3-4 days. It wasn't that long, but yeah, starting on last Sunday until Wednesday, Thursday, I'd say. Yeah. Cough, cough. I'll nugget. Yeah, no, I'm feeling fine. I mean, I started feeling fine pretty much. Yeah, I'd say after like 3-4 days, I was already feeling pretty fine. The occasional coughing, but nothing major. The first couple of days were pretty rough. My temperature was like fairly high, and I basically stayed in bed the entire for 3 days straight. After that, it was mostly like cold symptoms, but heavy cold symptoms. So I was lucky. I was very, very lucky. But yeah, I had to take a essentially complete rest for about a week. Also because after the cold symptoms, I started having a little bit of some like it wasn't painful, but it was hard to breathe at some point. So I couldn't like talk for half an hour straight. I was unable to do anything that involved me speaking for longer than 5-10 minutes. Hi Georges, hi Ivano. But yeah, it wasn't fun. Let's just say that. Like, climbing the stairs was interesting. Also, I was at home alone, which was, well, lucky for one side because my partner didn't get any COVID. They were out while I was in the heavily infectious part of the illness, and on the other hand, I had to do basically all by myself, everything by myself. So I had to have groceries delivered and stuff like that. So I had to deal with that. Luckily, like very, very luckily, my partner left on last Thursday, the other Thursday, sorry. And while I took them to the train station and coming back, I did some groceries. So I had my house was fairly stocked for the rest of the week at the very least, so I didn't have to deal with that immediately. But yeah, it's not fun. It's not fun to deal with that while you're by yourself. So which also meant basically taking a break from a lot of stuff that I was planning to do during the week, because I couldn't do anything in front of my computer. So I basically just had to press pause on a bunch of stuff that I was planning to do right before COVID struck. at the very least, it's well, let's just say it, I took a rest. uh yeah. I also changed the layout of the OBS, well, the OBS scene and the streaming layout. Now you can see my big head, like, and a small desktop at the same time, instead of being a small window, which is good. It's much more interesting, even though now you can see me reading the chat here. So now you know what I'm doing while I'm I'm talking about stuff. Let me just switch to this. Cough, cough. Yeah, Georges, you really need to find a way to add the ability to mute from the OBS input from Bosun, so I can cough and I can sneeze without having to move my mouse. I know a streamer that mutes himself before coughing and then unmutes and then does cough cough to notify the fact that he coughed. Because he's very polite. Oh, nice. Branch with 80% of that done. Great. Yeah, honestly, with more control over OBS, Bosun is already like 95% super useful to me. The other thing that I need to look at is being able to send dbus, basically to call dbus messages with specific payload or whatever. So you define the payload, because I want to be able to control a bunch of applications. Of course, then it requires having those applications expose actions and stuff on the session bus. That would be super useful, because I've seen what people use use the Stream Deck for that is not streaming. For instance, I've seen one of the people that I follow in YouTube uses the Stream Deck to control like After Effects or the video editing suite they use, or Photoshop or everything else. It's very, very useful because then you can just press buttons instead of like complex keyboard combinations or moving the mouse or stuff like that. It's very useful there. So yeah, that would be another fun functionality to have on Bosun. It would be interesting to have more programmability of our applications, to be honest with you. It was one of the ideas. So one of the reasons why we created the application API in GIO and GTK was to be able to program our applications. Applications would expose all the actions that they want to perform on the session bus, and then having other components just call those methods that basically use that interface. You could re-implement a lot of scripting stuff or external controls for applications. Basically transforming your desktop into something that is automatable or scriptable or at the very least controllable through other means than just the application itself. It was one of the initial design ideas of the application API in GIO. Because if you're exposing your entire menu structure on the session bus in order for the shell to represent it, or if you're exposing that in order to do things like the global menu bar on macOS, then the next step is exposing that functionality through something that is programmable, like scriptable. macOS has had that for ages and ages. Their script, they have a small scripting language that allows you to basically just launch applications, perform actions, close them, open windows, do various things, and even you can program it visually by literally just clicking a button and selecting a bunch of actions in a UI that looks remarkably like Bosun. So the fact that we don't have that, and we are constantly told that the Unix philosophy is tools being programmable. It's kind of weird. So yeah, maybe having Bosun and having a mechanism that allows you to control other applications would push more application developers to expose proper actions on the session bus from their applications. That would be cool. Oh. Right. It's Friday. So, chill. It's a good thing. It's also, April the 1st, and luckily for us, not many April Fools have been unleashed on the internet today. So, small mercies. I do hope that we collectively as a species stop doing that. It's such a bad idea. To be honest with you, I wanted to start the stream with my QT t-shirt on, just to fuck around. But then I realized it would have been bad. I honestly don't like that. Plus, let's be honest, the cute t-shirt that I have is pretty bad. It's since I don't put it on like ever, it's there just for a laugh. The plastic logo, cute logo, is so big and it's so like plasticky. It looks like a target practice, and it's so uncomfortable to wear. Did a game night instead of pigeon night? Oh, okay. Yeah, I mean, what was that? It was 2 years ago or last year that somebody just made the announcement that the KDE project and the GNOME project were merging into a single desktop called GNOME. That was moderately funny. Just moderately, but it was moderately funny. So, I mean, yeah. It was a simple joke. It didn't poke fun. It didn't poke fun at anything, and it was very inoffensive. People took it seriously. People took it seriously. They really wanted a single desktop. The same people that usually say Linux is about choice, and then like 5 seconds later they turn around and say, why don't we have a single desktop? The cognitive dissonance, it is strong. Linux is about choice, but fragmentation is bad. What? Yeah. It's pronounced GNOME. Not GNOME, not KD, GNOME. Oh god. Yeah. We would have removed all the settings, but every setting that was left would have been hidden behind a checkbox. So you had to enable the setting in order to use it. That would have been hilarious. Yeah. Honestly, yeah. That kind of joke. What was that? This was more than 15 years ago at this point. I think it was like around 2000. I still remember because I wasn't using it at the time. So it must have been more than 20 years ago. There was an April's Fool where Planet GNOME redirected to Planet KD and Planet KD redirected to Planet GNOME. And that was funny. That was the very last April's Fool joke that was funny on the internet. Yeah, it must have been like 20 plus years ago. Was it before GNOME 2 or around GNOME 2? Yeah, so it must have been 20 years ago. God, I'm old. I'm positively falling to pieces. Oh, yeah. Oh, sadly, I noticed right now you cannot see it, so I'll have to take it out. It's covered by the chat, so you cannot see it. But I got myself a little toy. If you ever seen The Expanse, this is a very nice toy. Have to be careful. Yeah, it was in pre-order from last year, so it arrived basically last week, I think. That is the Rocinante, the ship that the main characters of The Expanse are on. It's the extra large version, so it's like 30 centimeters in length. It's a very, very nice model, very well done, very detailed. I actually love it. So I got that, and then I finally built my Christmas present that you cannot see right now because it's off camera, but I built my Lego set, my Saturn V Lego set, which was my Christmas present. I got it and then basically left it there because I didn't have I didn't have the time. I thought I didn't have the time to build it, but it didn't take that long. So this is one part. It's so big. It's so big. It's massive. And it separates in all the stages, and it's so ridiculous how big it is. It's a meter tall. If I assemble it all, it basically just, it's so ridiculously large. And it took like what was 4 to 6 hours to assemble, like from scratch. It was a really good build. I was so impressed. And it's 1969 pieces, just to drive the point home. Just 1 second. I mean, this is how it's stopped. It is massive. It is ridiculous. It barely fits, yes. So this is what I did in the break while I was self-isolating because of COVID. Well, I did that, and also I did something else. How many hours did it take? About, like, I think, I'm not gonna say, it took between 4 and 6 hours. Just, yeah, roughly. More towards the 4 hours than the 6 hours. So, it takes a little bit, but it's not terrible at all. But yeah, aside from that, I also did this. Well, to be fair, I started this new project before COVID. Yeah, I think I did. So I started on the 10th. And yeah, I started it on the 10th, and I acted on it basically like the following 3 days, and then I had to take a massive break, and then I restarted it on the 28th. So yeah, about 8 days. But I did this. So I'm sorry, I'll have to mute the desktop sound because I don't want to be DMCA to death. I hope you're not hearing anything. Great. uh, I'm terrified of getting DMCA'd. So, but yeah, this is a little application that I wrote in as I say, like less than 10 days. Um, it's a music player that only plays music. Shocking, I know. Um, so one of the reasons why I wrote this was that um, early in the process of writing the getting started tutorial for the GNOME developer documentation, I was brainstorming on what kind of application should I write. And I decided to go for a very simple text viewer because it's the easiest thing I can do in on stream, and it's the easiest thing I can put together without necessarily going too deep in the woods of the rest of the GNOME platform. But I also was considering briefly media player, a music player at the very least. Cough, cough. Does it send email already? No, it doesn't send email. It might at some point. No, I'm actually actively trying to avoid doing anything that goes severely out of scope, like managing a music collection. That is already way out of scope. So yeah, writing a small music player was on my radar for a while. Mostly because the UI itself is very reactive. It has it's presentational only in that regard. It has to update itself depending on the contents, but it doesn't do user input outside of the playback controls. It doesn't do any user input. Load a file, present it, and then just get out of the way. The other reason was that it uses a component of the GNOME software development stack that is GStreamer, that is pretty prominent in our platform, which is pretty good. And I've never used GStreamer as an application developer before, so I'm not fluent with it at all. It's been nearly 20 years, and for me, GStreamer is pretty much a black box. File go in, sound comes out. How does it work? You cannot explain it. Which is all fun and games, but at some point, I honestly need to learn how, at the very least, how to put together stuff using GStreamer. And the other thing that I wanted to do was not use C for this, because I wanted to expand the scope of the GNOME platform to other languages. I did port the text viewer to Python to understand how to use Python, libadwaita, and GTK and GNOME libraries together. So, and then document them. So that's fine. I'm much more comfortable with Python than with other languages outside of C. Cough, cough. But I've never used Rust for GUI development. So, and since a lot of GNOME applications are actually moving actively to Rust, if they're not immediately written in Rust, then I wanted to see what was happening there. It's an exciting new development for the GNOME platform to have such a foothold in new languages and new platforms instead of expanding into them. At From a certain perspective, you can almost see Rust growing into GNOME instead of the other way around. Python already existed for a decade before, or nearly a decade before GNOME existed. Even Perl, same thing. Any other big language is already there. So was already there. Rust is GNOME predates Rust by about, I don't know, 15 years almost. So it's kind of interesting to see Rust adopting the GNOME stack instead of the other way around. And a lot of people are actively writing GNOME applications using Rust as the primary language for their projects. So it's kind of interesting to me to understand why that is happening, and how we can make it easier from the GNOME side so that people can take advantage of the GNOME platform instead of writing like a web UI for some Rust application, or using Electron, or using whatever else, and then running the application as WASM or any other thing. Because it's kind of important to be present there, to say, yeah, we are an option, and we are a good option for anything that is GUI related using this language. But yeah, that's why I basically started this project. This is the let's just say the altruistic kind of side, the personal side, the less altruistic and more yeah, more personal side is that I honestly dislike every single music player that GNOME has to offer right now. It's me. I understand that it's me, but yeah, it's me. I honestly and intensely dislike all of them. With the rage that burns like 1,000 suns, but mostly I honestly don't like one aspect of most music players in GNOME and Linux and everywhere else, which is every single one of them, everyone, is trying to re-implement iTunes. It's trying to implement iTunes better, but it's still trying to implement iTunes. And the fundamental problem with iTunes is that it's a database application that occasionally can play music. Well, in the case of iTunes, is a front to the Apple store, or a device management application, but mostly it's a database management application. You are placed in front of an application that essentially all it does is provide you with a UI that almost looks like a Microsoft Access from 2003 kind of application. I'm honestly shocked that people haven't implemented music players copying Excel at that point. And I kind of understand why that happens. I do understand why that happens. I have a 60 gigabytes music collection. I have it on multiple removable devices, and a copy on my NAS, and a copy on my desktop. And I do that because I have a ton of music that predates like music stores like iTunes or the Amazon Music or whatever else. And I'm legally required to say that it's legal. Stuff that I own. I own the physical media in most cases. Otherwise, it's stuff that I bought and I downloaded from stores like Amazon, Bandcamp, or SoundCloud, or whatever. So it's stuff that exists and it's legal. Yeah, most of it. I'll deny it, but yeah, it's legal. Get around, kids. Story time again. Yeah, music was sold on physical media. Yes, it used to be sold on physical media. At some point, it existed in that form. Shocking to know. I understand. Again, I'm old, but yeah. So when you have a collection that is like 10,000 tracks, thousands of authors and albums and stuff like that, then you kind of need a way to manage it. Sadly, well, not sadly, sadly for the applications that exist to this day that try to mimic iTunes and that particular kind of way to manage a music collection, it's already managed. It's called a file system. Every single track is inside, it's near the other tracks that are on the same album, and those albums are nested by album artist inside a specific directory. So I have already a database management of my music collection. It's called the file system. Shocking, I know. I didn't take all the music tracks that I have and shove them into a single directory using the SHA 256 checksum as their file name, which is a perfectly valid strategy if you want to. At that point, you are going to have to need some sort of content addressing system. It's also pretty stupid. Pretty stupid thing to do. And the other stupid thing is you have a fairly well structured like file system with the music already collected in specific places, and then you have to traverse it all and build a database that represents the exact same thing, but worse. Because now you're using the tags on the files instead of using the location of the file system. So suddenly, albums that have multiple authors just fall apart, and it's so bad. Oh, yeah. There was ages ago, more than 50 years ago, there was a music player that dealt with this stuff and dealt it correctly, and everything worked out really well for people with a large collection of music. No, not Banshee. Banshee did not. Banshee was another iTunes clone. The real MVP of music players on Linux was called Muine. It was also written in C sharp, but it was this. This is peak music player. You might not like it, but it is. Muine was the best. Redirection of this now. Muine was the best. It was the actual best. Oh, sorry, Federico. Hi. Yeah, Muine was the best. It was so good. I actually worked with one of the authors, Jorn Bayen, worked with me at Open End. It was this media player was the best. Using Mono and GTK Sharp, of course, and GNOME VFS, and default backend is GStreamer 0.10, but it also can use the Zine libraries because Zine was a thing. It was a very interesting time when GStreamer 0.8 was a thing and didn't entirely work, and then 0.10 came along. It was so interesting. Let me double check. Okay. Sorry about that, Federico. But yeah, so Muine was the best, and I love it. I loved it. I used it religiously until GStreamer 1.10 came out, 1.0 came out, and then GNOME VFS lost its shine because we had GVFS and GIO and GTK and glib and GTK, and GTK Sharp, of course, became unmaintained. So 2009 was the last release. But yeah. And yes, basically what I wrote is essentially Muine version 3. Of course, just like Muine was written in C sharp at the apex of the mono introduction inside GNOME, I decided to continue in that as it's called, in that on that road by using Rust instead, the hot new language, the hot new platform for GNOME applications. Yeah, it's the hipster way. Hi, Andre. Yeah, you may also notice that I stole some of the key shortcut from literally Muine. I looked at the code base to see what they were using, and I stole them. But yeah. So what I did was essentially try and rewrite Muine. It's not incomplete right now. It's missing some functionality, mostly a way to store the list of songs across restarts and store the queue across restarts. But I relatively don't care. it's very unlikely that I care about that. I'm gonna care about that. I'm gonna just use this to play stuff. Right. So since we are all here for this, I am going to go through the code base to explain how some of this stuff works. Because I know a lot of people are starting out and they have no idea how to structure a GTK application or a GNOME application using Rust and everything else. So I'm going to expose the fact that I know very little Rust and I'm terrible at it. So, well, the first thing I did was starting from I started from GNOME Builder's template for Rust. It's already pretty good. It's not complex at all. You can follow along most of it because it's well structured. You get the build system integration with Mason, you get the Flatpak integration, you get everything pretty much reasonably ready for you to start hacking on it. The overall idea is that literally you create a new project with GNOME Builder latest version and you get a fairly solid foundation. Let me see. So yeah, the initial import was on March the 10th. So it was the very basic commit for the project layout. I like to, I'm going to compress all the history into a single commit because I like the first commit of my project to either be the very basic functionality ready, or at the very least same baseline that people can look at. But for the time being, there is a little bit of pretty shitty commit logs, like cleanup. I'm terrible at that. You will not see this in a public repository. This is all local. But yeah, on top of the very basic template, what I added was the code of conduct, the README file, and an editor config file for the controlling the text options for my project. It's very basic stuff. I also added the reuse and licensing terms, so I have everything that is all the license used in the project, CC by SA3 for the assets, GPL v3 for the code, and CC0 for ancillary files that have no business being licensed with anything except the public domain license. So that's very basic stuff. It's nothing to phone home about. But yeah, so okay, if we go into the source code directory, the very basic stuff that Builder puts there is an application file with the application class, the G resource for the various resource files, and the window file for how the main UI is supposed to look like. Both application and window subclass. In the case of application, it will subclass GTK application. Adwaita application in this case, and the window subclass is GTK application window. Okay. Yes, I'm gonna re-enable that. So very simple stuff, very basic. And then you have the main, which is the main entry point, creates the application and runs the process. So one of the first things I did was actually to define the base data type for a music player. At the very minimum, we are playing songs. So I created a song object. Now, you can... There are many ways to do this. This is the one I preferred. I understand that a lot of this stuff is probably post-hoc. Post-hoc. It's not... It's mostly rationalization about what I'm doing, what I've done. There are other ways of doing this. So I started with a basic Rust data type. The data associated to the song file. The artist, the title, the album, the duration in seconds, and the file that is the actual on-disk representation. I'll explain why I use a 64-bit unsigned value here in just a second. So the basic entry point is you create a song data object from a path, and the path, this is Rust gobbledygook to saying pass everything that looks like a path and turn it into a path, a reference to a path. So you can pass a string, or you can pass a constant string. String is an allocated string. Str is the equivalent of const char, like a static string, and turn it into a path object. Very, very simple stuff. That happens to be what taglib requires. So if you've ever seen, if you ever had anything to deal with music files and things like that, you will know that taglib is a small library that looks up for metadata attached to a music file. So ID v3 for MP3, or the metadata associated with OGG files, or like FLAC or whatever else, M4A, AAC, whatever. Ages ago, and I'm talking literally ages ago. Let me see. Yeah. So in 2015, so this is how long I've been planning to write a music player. So in 2015, I wrote the Rust bindings for taglib. It was my first Rust project. So I took the C API for taglib. I wrote the wrapper around it in order to call it from Rust using the FFI interface, and then I wrote the Rust wrappers around it. I never managed to release 1.0 until somebody came along that wanted to write a small music player and wanted to use taglib, and basically he just brought it over the finish line. So Chris Down did the last bit. Well, not the last bit, but he made it work on modern Rust, and made it work on Windows and other platforms. So he's the reason why taglib Rust actually exists on as a functioning project, as a usable project. It was functioning before that, but yeah, that's mostly it. So the what I've done is essentially just load the metadata associated to a file, grab all the tag. The tag object is what contains the artist, title, album, all the metadata, stuff like that. And then there's also the audio properties object, which contains stuff like the number of channels the music file has, the length in seconds. The length is a unsigned 32-bit value. So originally the duration was U32, not U64. And what the song data object does is nothing else but whenever you set the URI, it will extract everything, fill it up into the song data object, and that's it. That's all there is. Of course. I have a default implementation there with a neutral file. This is not precisely how you would do it in regular Rust. This is a very prime candidate for an immutable object post-construction. Typically, you would create a song data and will never modify it ever again. So you create it with all the fields already set, and that's it. Of course, artist, title, album, they are optional. They are optional because a song might not have a title or an album or an artist, which means that it's the equivalent of being nullable in C. Okay, right. So in theory, this one should not be a setter function. It should be part of a constructor. You do song data from URI, and it creates a song data object for you. The reason why I have to do this way is because the next step is to wrap the data inside the GObject. So you create a GObject class that contains the data here. Now we go into the woods of how GObject in Rust works. GObject as a concept is not immutable. It cannot be immutable. So its data inside it has to be, so you pass it around, but you cannot pass it around as a mutable object all the time because it would make your API pretty terrible. So what you do is every single field inside it, this is, let's just consider this as the private data, the private instance data, the equivalent of the private instance data for a GObject class in C. What you do is you create this wrapper object around it, and then you define the properties that it has, and the set property and get property, and everything else around it. And all it is essentially just again a GObject wrapper around the data object that exists here. As I was saying before, another way of doing this is instead of having a complete object here that you reference from within the wrapper here, is have every single field as separate, like data. It's exactly the same up to a point. It's very, again, I think this is mostly rationalization on my side. But the overall idea is that the data around here never changes. It's just the object here that can change. So once you load the data from the song, everything there is fixed. It won't be changed. It's immutable. The real mutable bit is this part of the wrapper around the song data. So having all the fields being internally mutable is kind of pointless. So the reason why I did this wrapper GObject around the basic Rust type is that I want to be able to bind the data inside the object to a widget, for instance. And in order to do that, you need to have properties. In order to call GObject bind property or to use GTK expressions, you need to have properties. And you cannot add properties to a Rust object by itself. You need to inherit from GObject. This is not like rocket science or something, or completely new information. If you want to use GObject, you have to use GObject. So what I've done here is essentially just defining the gparm spec for all the properties that a song has. And then the only writable property is the URI one. So whenever you get a new URI, you set it, and then you notify all the read-only properties here. And then for the property get property, you just return the internal data from it. It's essentially like writing a GObject wrapper around a random structure. Of course, in C, you would not have a random structure. It would be the private data associated to the GObject instance. Shocker. You can imagine it as if you put the all the fields you have inside a separate structure, and then put the separate structure inside the instance private data. That's it. And then you just create a bunch of public API for it. You create a constructor that takes a URI and basically creates a new instance. There's another constructor that creates an empty song. There's an equals, and all the accessor functions. So you can call these methods and return the data there. The one thing that changes from the internal representation to the external wrapper is that I want to return default values instead of nullable values. So I return, if the artist is not set, then I will return a well-known string, and then it's going to be localized. That's it. That's the main difference. And yeah. So this is the core stuff. This is how I started the project. I created a representation of a song in Rust, and then I wrapped around the data structure a GObject, so I can get notification whenever, not only I can get notification when stuff changes, which shouldn't, but also I can bind properties on the song to other things like the GTK label, for instance. So I can print out the artist and the title of the song. And this is kind of the core of how to write a GTK GNOME application using Rust. You have to figure out the data types that you are going to use, and then whenever you want to present them to the user through the lens of a UI element, you wrap those data types using a GObject. So you can then use property bindings or expressions to build your UI, to update your UI. It's kind of the core tenet, and it's not just for Rust. It's for any new application that you're writing. You should apply this model view pattern. It's kind of a model view pattern. It's just you have the model that is your data, and then you have the view, which is your widget, and then you bind those through using the API that GObject provides you with. So you can do this in Python, you can do this in C, you can do this in Perl, you can do this in JavaScript. It's how we expect new GTK/GNOME applications to be written these days. Rust makes it a little bit more obvious because of the overall data types are supposed to be immutable by default, and they should not be mutable. If they're mutable, it has to be explicit and stuff like that. But of course, Rust doesn't have the ability to notify of changes inside their data types. So you have to provide that functionality yourself. And GObject does that for you, which is the good bit. So yeah, basically this is the core of the data. This is actually the only data type of this application. The rest of the application is just a way to manipulate a list of these types, and then present it to the user. And then there's the little bit of like code that deals with load a file using the given URI, and then play it using GStreamer. It's actually very limited in the variety of things, but it's the way you combine the three elements. So the UI part, the data that you're loading, and the playback machine. It's the way you combine those three elements that basically gives you a media player. So let's look at the media player, because it's actually the most complicated thing. This is actually the thing that required the most time for me to grasp. And also it's the thing that requires the most care, and it also will require complete rewrite. Well, not complete rewrite, but a rewrite at some point, because that's just not how stuff should be working. But the way it's done is again fairly basic. So let me see. Right, let's start from the outer part. The outer part is the audio player object. It's the thing that will control GStreamer, and in this case the Empress, the media playback remote interface service. I don't remember what Empress stands for, but it's basically the thing that allows you to control media playback from the shell. Yeah. Let me close this. So this part here is what lets you control the media playback from the shell. It presents you what you're playing. In this case, I'm currently playing Spotify on my browser, so it looks like that. And this, you can control it and stuff like that. It's a massive dbus interface. the shell recognizes it and presents it to the user as a notification, as a permanent notification. If I add more media, like my media applications, they will all appear here and will be controllable individually and separately. But it's also what allows you to do things like using the media keys on your keyboard. The shell will receive the media keys events, and then it will send them to the will control the Empress implementation there on its side. It's very useful. It simplifies a ton of stuff. I still remember back in the day when, in order to do media keys in GNOME, you basically had to listen to a weirdo interface somewhere, or you literally had to grab the media keys for yourself from the windowing system. It was mental. So no, these days there's this interface here, and there's a Rust implementation that uses dbus behind the scenes for you, and it's great. So if possible, always use that. Don't reinvent the wheel. And for playback, we have GStreamer Player, which is another it's an interface part of GStreamer. It's in GStreamer plugins bad, I think. It's going to be replaced by GST Play in the near future, but right now GStreamer Player is basically just a wrapper around GST Play, which is a wrapper around Playbin, which is the element of the GStreamer pipeline that plays music. It's very like basic stuff. So audio player is the object that keeps track of these two bits here, the GStreamer player and the Empress player, and that's it. And what it does is it will provide you with an API to play, pause, stop the playback, skip to the next song in the queue, skip to the previous song in the queue, to a specific position, and seek backwards and forward X seconds. And this is the hard part. It will also deal with keeping track of the current state of the playback. So the current song that is playing, the next song, the previous song, and a bunch of other state stuff. The main problem, which is what kind of plagued me in the very beginning of this project, is that GStreamer is entirely unlike any other library that I'm used to. GStreamer is heavily threaded, which means that stuff happens in different threads, and then just signals get emitted, properties are changed. And that can happen from any thread, because why the hell not? And Rust and threads are a thing at the language level, at the type system level. So the typical way of doing this stuff, I've been told, is that you have an object, and then you basically just connect to the pipeline that you build, and it will emit events on the bus, on the thing that connects the entire pipeline from start to finish. And since those events can happen from any thread, everything has to be thread safe, and you cannot manipulate anything from within those threads. Especially, you cannot manipulate stuff that is very much single-threaded, like GTK. GTK really does not want you to use its API from different threads. It will blow up. And it will blow up for a very specific reason. Only one thread at a time can control the windowing system state and the GPU. And we have a ton of stuff that manipulates everything. And lots of global state, lots of stuff that is attached to the global state. So GTK is very, very much a single threaded API. So the way I'm used to working with GTK is that you have GTK, which runs on a single thread. And then if you have stuff that has to happen without blocking it, then you spawn off another thread. And then when the thread finishes, you re-enter the main thread and update the UI. Very, very trivial, very simple. Works really well with IO and IPC mechanisms. It's perfect. GStreamer is the other way around. GStreamer is anything can happen in any thread, which means that from any thread, you have to send a message to the main thread, that the thread that manipulates the UI. Hi, Paranoid Polaroid. Even with GTK single threads, yes, that hasn't changed. That hasn't changed at all. It's all single threaded. Only a thread can access the GPU. Only a thread can access the windowing system loop. You have an entire state of the UI that is accessible from the current thread, like event handling, layout, what else? Drawing. That has to happen on the same thread. It cannot happen on different threads. If the only way to make it happen from different threads is if we basically just either lock down every single thing. So every time you operate it on any GTK object, we would acquire lock on that object. Or if we deferred everything. In theory, now that GTK has the deferred, well, the retain API for rendering, it would be possible to just operate on a single thread and then send stuff over the GPU to not block the main thread. But it hasn't happened yet because it's kind of complicated anyway. And it doesn't really matter at all because layout, for instance, has to happen on the same thread. Same as event handling. If we wanted to do those things on separate threads, we would need to basically create a retained graph of layouting operations, and then take that graph and copy it over to another thread, and you would never be able to access it directly from the widget, from your user code. And the other thing is event handling. Event handling has to manipulate the state of the widgets, for instance, and that has to happen on the same thread that is spinning the main loop. So yeah, GTK is very much single-threaded, and it will require a dramatic redesign to make it happen make it use multiple threads. So it's not easy at all to integrate GStreamer, which is everything can happen in multiple threads. It's fine. Doesn't mean anything. With GTK, which is no, everything has to happen on this thread, otherwise I will blow up. So I've been looking around existing GTK Rust applications to see how people do it, to see how they do it. And I found two approaches that are one is more idiomatic than the other. Let's just say that. So let's start with the more idiomatic way. The more idiomatic way is, in your application, you create a bunch of actions, and then you create a channel, in the Rust sense. So with a sender and receiver across threads, and you create that channel so that it happens on it get pulled on the main loop, which happens on the main thread, which is what GTK uses. And then every time something changes inside the GStreamer pipeline, you literally send a message from that thread into the main loop, and then the main loop receiver end of the thread will just look at the message and then do something. That is the kind of idiomatic way, and people should actually do that, because it's how you're supposed to use GStreamer, and how you're supposed to use GStreamer on Rust, and how you're supposed to write a GStreamer application that has a GTK GUI. The other way, which is what I used, is different, and it's kind of less idiomatic, but again, it's used. So what you do is you create a wrapper around your the Rust object that manipulates the GStreamer playback, and you basically just say, okay, everything is going to happen in the main thread anyway, because it's using GStreamer player. GST player can be told, please emit all the signals inside this specific main context, which is glib speak for the thread that runs the GTK main loop. So we can tell GStreamer to do that for us. The problem is all of this is done at runtime, and the type system doesn't know that. The type system still thinks everything can happen on any thread, which means that you have to satisfy a bunch of constraints on the API. Those constraints live at runtime, not at compile time. So in order to do that, there is this little bit of a hack called Fragile. Fragile takes a pointer to some data, in this case a reference counted data type, and it wraps it around it with something that is technically thread safe, or technically satisfies the type system constraints. So basically you just connect signals on the player like you would do on any GTK application, where you basically sit waiting until you get a signal emission on something that happened. You have to do a lot of wrapping around stuff. So I have this object here, which is a very simple Rust structure, and then I have to wrap it around a mutable container, ref cell, a mutable container for references, so it's an allocated pointer essentially, and then wrap it around again a reference counted type. So this one adds reference counting to a pointer essentially. And then what happens is I have to wrap it around this type here that does not do anything except satisfy the constraints of the type system. And every time I have a signal emitted on the player, on the GStream player, I have to do some bunch of magic to basically say, okay, give me the contents of that bit of data that exists. And after that is nothing more than just figuring out what needs to happen whenever GStreamer tells us that something has changed. For instance, this is the end of the stream, so whenever a song ends, we determine whether we have to continue to the next song, stop, or repeat, depending on some internal state. This case is the position update. Position update signal is just we advanced in a certain amount of time, so this is how much we advanced inside the stream that we're playing. In this case, the media info updated is when GStreamer has finished loading the metadata attached to a file. We use this for updating the cover art. Because sadly, taglib does not let us do that. So taglib is actually a C++ API that has a C wrapper around it. The C wrapper is incomplete. The C++ API has the ability to read specific tags like ID3v2 or the v1 or whatever else, and if you have access to that, you can extract stuff like album art or more tags. The C API does not have that, and so the Rust API does not have that. I would need to create a Rust binding for the C++ API, which is not really my idea of fun. Compared to GStreamer, Empress is like a walk in the park. The problem is Empress is not written the same way that GStreamer is written. So it watches the session bus for methods, method calls, property changes, and stuff like that. So it has some of the same type restrictions that GStreamer also has. So it makes sense to have that inside the same place. Native ID3v2 lib yet? I have no idea. I don't know if somebody wrote that in the past 7 years. I honestly didn't check. My bad. I mean, it's not incredibly hard to write metadata tag extractor in Rust. Is probably a bunch of num and stuff like that. Yeah, no, GStreamer supports ID3, and this is what I'm using to load the image data. But I would need to set up a GStreamer pipeline to load the metadata out of an object, out of a file, in order to build a list of songs. And I don't want to do that. I prefer to use taglib, which only reads a fragment of the file and takes no time at all. So I actually use GStreamer to read the metadata, a very specific bit of metadata, but not all of it. And I would use taglib very much more readily if I had the API available to me. I would not use GStreamer to load the metadata at all, because you will see what happens when I do that. Yeah, the Empress part is very basic. You connect to play, pause, stop, previous, next, and raise. Raise is kind of an interesting bit because I have to use GTK API inside something that should not be using that. I will probably have to modify this so I will emit a signal, or I don't know. it will have to do something so I can move this bit of code from the player into the application itself. Because right now I have to get the application default and the application singleton, and then get the active window and then present it. And it's a bit of GTK that doesn't make any sense to have it here. But yeah, it's kind of a... I'm kind of nitpicking, but this is not great. This should not be here. So all of this is doing is not manipulating the UI at all. It doesn't do anything with the UI. It manipulates a state object here. And the state object is what we were looking for at the very beginning. So the player state object is actually a GObject, because we want to have the state object notify the UI so that the UI can update itself whenever the state of the player changes. And in this case, since it has isolated components, it doesn't do what the song object did. It has separate fields that are unrelated usually. So it has the playing field, which is, am I actually playing? Or the song that is currently playing inside the queue, the length of the song, the length of the queue, and duration of the current song, the position inside the current song, what is the repeat mode, the current song object, the current cover. Again, this one is, I would like to move it inside the song itself, but it's kind of complicated. And the queue, which is a list of songs. Again, there is nothing related to the UI here. It's all related to the player and what the state of the player is currently. And then it has a bunch of properties. As you can see, they're all mostly readable. So, sorry, they are all readable. Again, the UI does not modify the player state. The UI modifies the player. Sorry, not even modifies. The UI calls API on the player. Please tell me the where is it? Please clear the queue, or play, or pause, or stop. It doesn't modify the data inside the data structure. It only tells you, it only gives you a way to perform commands. And those commands have an impact on the state, and the state notifies you of changes there. So this is the model. This is the controller, and we'll see the view later on. But yeah, that's basically it. It's model view controller repeated over and over and over and over again, so that any change on the control applied on the controller will be reflected inside the model, which will be bound and displayed by the view. It's very basic MVC pattern like behavior here. There's nothing magic at all. It's 30 years old software engineering best practices. I don't know, when was the Gang of Four book out? I think 30 years ago. It's early 90s? I think so. But yeah, there's a bunch of indirection here and there, and it's there because of the way stuff works in Rust. It's not It's similar to how GObject in C works, to be honest with you. Even though it's called imp for implementation, it's really for a GObject C developer. Whenever you read imp, you should really read priv or private. This is the private data for a public API. That's it. There's nothing else there. Once you understand that particular bit of, I don't know, of, it's not even coding style, of like the little bit of design inside the entire thing, the habit or the practice of doing this, and you map it to what you would do in C, it immediately becomes clear what everything does. Everything else is just satisfying the requirements of the language to ensure that everything is type safe. And of course, when it's type safe, it also is memory safe, and like the lifetime is correctly evaluated by compiler and stuff like that. So you don't access stuff that doesn't exist anymore, or you don't leak stuff too much on the floor. You can still leak things, but again, it's just lifetime tracking. Instead of assuming stuff like you do in C because the documentation tells you to, then. And here we come to the reason why the duration and the position of inside a song is a 64 unsigned integer. It's because I'm using GStreamer, and GStreamer clock is unsigned 64. That's it. So yeah, it's ridiculously large. It's like, oh, your next song is gonna take like 4 billion seconds. Yeah, okay. But yeah, that's basically it. So if anybody has questions, like, feel free to ask them. I'm just going through the implementation here because it also helps me. It helps me explain it by going through it, and also allows me to really understand what I've done instead of like figuring it out afterwards. But basically, just if you have any questions, just feel free to ask. This is mostly just a bunch of API calls to libraries. There's nothing clever here. The main thing that I've asked on the Rust channel on GNOME's matrix server is, okay, I have the media metadata, and I want to extract the image data there and then feed it to GTK. How do I do it? And luckily for me, very competent people are there on the Rust channel, and they told me how to do this, which is mostly, again, getting the buffer data out of GStreamer and then into a simple bytes buffer, and then I can use GDK texture to load it up, and then this stuff gets uploaded to the GPU by GTK itself, and I don't have to care about it. Luckily, GTK 4.6, which is the current stable release, has a new API that basically just, if you are uploading a PNG or a JPEG, it will automatically decode it for you from the bytes buffer and then create a texture, which is great. So I don't have to do an intermediate load inside GDK pixbuf, and then from GDK pixbuf get the RGBA data and put it inside the texture. Great. One less thing to care about. Of course, if somebody decides to put some other file format inside the cover art of their songs, then this stuff will fail, but I don't have to care about that. And yeah, another bit of like logic here that is not literally calling a single function is how to seek into a GStreamer player stream. Basically just use the match operator for to see if we are seeking backwards within the how's it called, if we're seeking backwards and we have enough room on the left hand side, then we just subtract the new direction, the offset. Otherwise we go to 0. And if we are seeking forward and we are going to if we have enough room on the right hand side, then just seek forward, otherwise go at the end. And then the magic happens. The magic happens somewhere else that I don't have to care about. Again, it's pretty easy to call into stuff. The logic here is very, very basic, so I don't have to do anything complicated. There are a bunch of stupid things that I've been doing that I should not be doing at all. Like, for instance, I keep current track of the current song object, but I also operate on the index inside the queue for that particular object. I should not be doing that. But yeah, again, it's something that I will have to fix when I also fix the entire player state tracking here. I should not be doing this using signals. I should be doing this using the message bus. A lot of this code would not exist here, for instance. It would be moved somewhere else. But yeah, now that we've seen the basic data type and the controller of our player and the model which represents the state, then we can see the presentation of that state. And we go into a window. Window is a GTK application window. Well, in this case is an add weight application window, because I don't want the header bar. I want to have a completely flat surface, and I don't want a title. I don't want anything else. I just want that. And everything is done using templates, because it's 2022. I'm not going to build my UI using code. I'm going to use a very, very simple XML file that describes the entire thing. Every control, like every button here, is actually not managed with a callback, but it's managed using actions. Because this makes it a lot easier to deal with. You would not believe it. It's so much simpler to deal with this stuff if you use actions. Because when you have actions, you have the ability to enable or disable the action in a centralized place. You also have the ability to attach a key shortcut to the action, which gets enabled and disabled alongside the action. And it will have a representation inside the menu, for instance, or it will have a representation inside the key shortcut window. So it's all very, let's not connect to the click signal of every single GTK button, and then from the GTK button deal with a bunch of other stuff. Just define the action, and the action will get invoked and by name, and then whenever that happens, the UI control will deal with that. So we have our window with all the UI elements that we care about. So all the buttons, all the labels, the queue, the album image picture, and then we have a reference to the player. And we use the wrapper here, so we have access to that. Again, subclassing stuff from in Rust from GTK, in this case add weight application window. We bind the template. This is all stuff that is generated for you by GNOME Builder on the basic template. I just added a bunch of code here, nothing special at all. And then I install the action. So whenever I install the play action, and whenever the action gets activated, I either pause the playback or I play the playback, depending on whether the player is actually playing. That's it. I don't have to have a signal callback or anything else. This is what is necessary. Nothing more complicated than this. And it's using closure, so it's all inline, and you can see it's literally 2 lines of code. 3 if you count the debugging note. But that's it. The closure here is just nothing special. I used a different domain here for the queue related actions. I should actually move these actions from the window namespace to the playback namespace probably. It doesn't change anything, it's just probably a little bit more clear what they're to separate domains like that. And yeah, again, that's pretty much it. These are like a bunch of setup. This is a bunch of setup API internally that does things like connecting to the signals, initializing the action to their basic state, binding the state of the player of the playback to the UI, set up the queue, and in this case restore the state of the window that is saved into the G settings. So if I resize the window and then close the process and close it and then relaunch the application, the window will have the same size. Again, stuff that is pretty much the same across multiple languages. This is not doing anything special. I also have a couple of this is an ancillary function that creates a GIO settings, a G settings instance. The application has 2 IDs. The first one is during development time, and the second one is during stable releases. But I want to ship the same setting schema, so I don't have like 2 of them. So I just tweak to remove the suffix that I use for development. This is entirely unnecessary if you don't have this particular requirement of having 2 application IDs. Sometimes it's useful if you want to have like the installed version like in your system, so you can keep using it from the stable branch, and you want to develop while the application is actually running. So having two prefixes avoids if you have most applications are single instance applications. So if you already have an application with the same ID running, you cannot run it again from the development branch because they will conflict. So it will terminate immediately. The second one will terminate immediately. What you want to do is have another ID so you can run them in parallel. That's it. That's the explanation for it. But again, very trivial stuff that it's valid on any language, and it depends. I mean, yeah, in this case, it's not entirely necessary, because if I am listening to a song because I have the media player in the background and I'm listening to a bunch of songs, and then I'm also developing the same media player, I'll have to test it and listen to another song, and listening to two songs at the same time is not something that happens. So it's kind of, yeah, it's kind of overkill. But if I had a different kind of API, a different kind of application, I would probably, it would probably be more of a requirement. Yeah, this is pretty simple stuff. Again, this is the way to restore state saved inside G settings. In this case, we are restoring the window width and window height whenever we start up. Simple stuff. There's an entire tutorial on the GNOME developer documentation website on how to do this, so I'm not going to spend any time on this. This here is a yeah, these are internal functions that are going to be called by our action here. For instance, yeah, add a song, add a folder, or clear the queue here. Because they're kind of complicated, I could call this from within the handler here, but it's probably a little bit clearer if I do this from within a separate function, just for readability's purpose. It's not a requirement or anything. Adding a song instead is kind of more complicated because you have to create a file chooser dialog. We're using a file chooser native because this application runs sandboxed. So we are creating a file chooser native here that opens a file. We add a file filter, so we only show audio files. And then we connect to the response signal, so whenever we accept the file, we add it to the queue. The interesting bit is not something that a lot of people encounter normally in other languages. We are capturing the dialog variable here, so we can use it inside the queue, inside the callback here, and we're also capturing the window. We're capturing self, which is the window. We capture it and we rename it as win, so it makes it clear what it is. But the reason why we are doing this with a weak reference to the window here is because the window exists. The window exists outside of the lifetime of the dialog, whereas the dialog has to be a strong reference because GTK file chooser native is an object. It's not a dialog. It's not a widget. A widget, well, a GTK dialog would, since it's a top level, would exist referenced by the toolkit itself. Native file chooser is a GObject, so it means that at the end of this scope, it would go away. So we tell the closure here to keep a strong reference on the dialog, so it keeps existing until the callback runs its course. In Python, you would need to keep a reference on the dialog itself via some other mean, like adding it to the window as a private field. Rust is more explicit about this, and the clone macro that glib, the glib Rust, the GTK Rust bindings provide has this kind of neat little syntax that allows you to deal with this. Do you ever run repo for your code? No, I don't have a repo because, again, it's not ready yet, but I will upload it. It's a thing that will happen as soon as I have it in a more reasonable state. Again, this is the product of 8 days, and I had COVID in between. So it's like 3 days, COVID, then 4 or 5 days. Yeah, this is how to add a song. Pretty simple. This is how to add a folder. The folder is just go through, enumerate all the files inside a folder, and then if it's a music file, add it. That's it. The GIO has API to do exactly that. So yeah, it's pretty trivial to deal with this stuff. And this is actually the interesting part. We are binding the player state to the song labels. So let me do this. Let me run it. I resized it before. So let me add a folder here. So we add a folder here. So the player state loads the song, the first song in this case, and then it sets up all these read-only properties like current title, artist, album, which is the time, which is this one, and the cover here. And it's all done using property bindings. It's all not done using like having the player manipulate the UI directly. We set up the state, and then UI just reflects that state. Again, model view controller all the way. Not everything can be done that way, because sometimes it's more complicated. There is no just single properties that will do it. So for that, we use the raw notify signal on a property. The bind property method does this for you, but essentially it's exactly the same thing. So whenever the current song changes, a little bit of logic to enable or disable the previous and next buttons. So the previous action is going to be enabled, which will enable or disable the previous button, whether or not we are at the beginning of the queue, or the next one will be enabled, disabled, depending on whether or not we are at the end of the queue. Very, very simple things. But again, we are not accessing the widgets themselves. We are accessing the action here. And accessing the action allows us to not having to care about the widgets at all. We enable the action on the window, and if that action is enabled, the button will be sensitive. if the action is disabled, the button will be unsensitive. We are not manipulating the state of the widget themselves, which is very much a lot cleaner, very much more conceptually simple to understand. And this is whenever the queue changes, depending on the number of songs that we have, we enable bunch of state or disable a bunch of state. Like, if there are no songs in the queue, then the play, the pause, and the seek buttons are disabled, because of course they are. There is nothing to play and there's nothing to move to. And if there is more than one song, then we check the current song and then we change the state of the previous and next button. And if the player is playing, then we change the icon of the play button depending on that. Again, pretty simple stuff. Same thing for the repeat mode. If the repeat mode of the player is one of these three values, we change the icon. So let me see. So we click it once and we go into repeat all. We click it again, repeat one, click again, and the consecutive. And that's it. Oh yeah, whenever we close the window, then we save the current size inside the settings. Again, this is a tutorial on the developer documentation website of GNOME. You can look at it and it will be easy to replicate. Right, so this is the last part. This is the last bit. So how do we deal with the queue here? So the queue is kind of a new feature of GTK. So we store all the song objects inside a GIO list store like object. A list store is a very basic data structure that operates like a list. Internally is not a list. Internally is I think it's a splay tree. I think we changed a couple of things, but it's basically a tree of things. So insertion, sorted insertion is fairly cheap. Well, cheaper than like basic lists. Iteration is linear, blah blah blah. It's fairly nice. It has a series of fairly nice properties. It also can scale up to millions of elements, so we don't have to care about that particularly. One interesting side effect of that is that GTK4 has a ton of widgetry that takes list models, which are the basic interface that is implemented by the list store object. More importantly, GTK4 has a couple of widgets, one of them being list view here, which can scale with thousands, even millions of elements. Of course, a queue of songs is not gonna be millions of elements, but it's gonna be pretty big. Can be like in my case, if I wanted to add every single music file that I have on my system, it would be like 10,000 rows. In order to make it scale, GTK list view uses what is essentially a recycler view, like Android does. So you only see a bunch of rows here, and then whenever you scroll down, GTK will just replace the contents of the widget inside the row with new data coming from the model. This is the rough explanation of how it works. So you never instantiate more than, I think we limit that to 50 widgets or 100 widgets. I don't remember the precise number. So the performance of the list view widget remains fairly reasonable, even in the face of a dataset that spans for millions of rows, which is, you know, pretty cool. It's a pretty cool functionality. And in order to use it, you have to do a little bit of a setup here. It's not hugely complicated, but it can be a little bit of a conceptual like step that not many people factor in at the very beginning of a project. Like, it's not GTK listbox. GTK listbox is a very simple version of this API. It doesn't do recycling views. It doesn't do a lot of stuff there, so it doesn't scale as much. It's good enough if you have like 10, 50 items, but if you grow above that, then it can be pretty complicated to deal with. But the overall idea is it's kind of the same. You create a list view here, and then you say, how does it behave when it when the user wants to select something? Does it have multiple selections available or a single selection? And you say, okay, this is a single selection list view, because of course we don't want to have like bajillion songs there selected. We only want to select one to switch to that song, which, by the way, I haven't implemented yet, so I cannot demo it, but this is how it works. So you create a single selection object and you feed it the list model, in this case the list model of the list store of the songs. We already have it here. So we don't have to do anything fancy about it. We have a queue that already stores all the songs that we loaded up. So we don't have to do anything special there. And then we set it as the model. We set the selection as the model for the list view. At that point, we have to tell GTK, okay, so we have the data inside the model. How do we turn the data there into something that we can represent to the user, can visualize as a row inside the list view? In order to do that, we use what is aptly named a factory object, because Java taught us nothing. In this case, we use a signal factory because we want to use signals to build up the entire thing. You can also use a builder list item factory, which instead of using signals will use a UI definition file that you have. So it will load up the UI definition, build everything out of that, and then add it to the create a row out of that UI definition file. It's pretty it's more appropriate if you have a complex UI, but if you have a simple UI, then you can use a signal list item factory. And you have two signals there. The first one is the setup, which is basically just it's called every time the list view has to create a new row inside itself. So we have a fancy widget that is just a couple of labels there. And then we set it as a child of the item. The second signal is what does the binding between the element inside the list model and the row widget. So whenever the list view scrolls past the region of the model that is currently displaying, so it's a sliding window, whenever the scrolling happens to go outside of the currently displayed list of items, the contents of the widgets, the rows that are not part of that row, or not part of that window, will be unbound, and then the new rows inside the model that are now visible will be rebound to the new items inside the model. So we replace the song title and the song artist, and we say if the row is representing the song that is currently playing. In this case, it's not, but that's it. And then we set the factory object here, and that's all there is to it. This is all the thing that does the magic. Create a row, and then whenever the row has to change, fill it up with the contents of the song object that we have. Hi, of course, Zandora. Oh. Oh, glad it was useful to you, and congratulations on the 1.0 release of your program. Yeah, great. I'm happy for you, and I'm happy it was useful. I mean, I wrote that blog post mostly because it was there was no documentation whatsoever at the time. It's just that a lot of the documentation that you could find around the internets were referring to really old stuff that was relevant in the early days of GTK 2, and I decided, well, I'll write down how to use this stuff that I wrote. The API was there for a reason. I mean, that API, I wrote that API, and then the entire thing was available there, and I'm happy if it was useful to other people. Yeah, another thing that was mental is that everyone is still trying to use GL1 or GL2 in 2022 with, oh, let's call GL vector and GL begin and GL end, and then load the matrix and stuff like that. It's like, no, doesn't work that way anymore. It's kind of an greatest hit on the GNOME discourse. People find the red book, the GL red book, and think, oh, I can use that. GL doesn't work that way anymore. GL is very much not that way anymore. Yeah, I understand completely. Yeah. It's also the reason why I wrote an entire example that basically uploads the triangle with a bunch of shaders there. Otherwise, people will not believe me. Oh, if you have a 1.0 version of your program and it's a GNOME application, then you can also use This Week in GNOME if you want to. It's a great service. You end up on Planet GNOME. If it's just GTK, it's fine. Yeah, you can send it wherever. Yeah, This Week in GNOME is probably going to be out in half an hour. So if people here are working on GNOME applications and want to have them publicized, then join this week on the GNOME Matrix server and then present your stuff to the community. It's great. It's a great way to publicize your work, and you make the news. Yeah, as soon as I'll have other people use this little application that I'm writing, I will also publicize it on This Week in GNOME. I actually need an icon first. I asked on the GNOME design channel if somebody wanted to design me an icon, but I haven't had anybody like take the bait. So I'll have to wait a little bit. My usual strategy in this case is I'm going to launch Inkscape and I'm going to commit a crime against humanity. And then one of the designers will look at it and we'll redesign the icon. Oh yeah, candy. I don't have any candies. I live in London. What kind of candies do I have? I cannot send a I don't know, a sticky toffee pudding to Jimac. It's pointless. He has a better quality of sweets. I could send him some jelly babies maybe. Oh. Yeah. So let me. Yeah. So I'm going to mute my desktop again, so I can show you how the UI reflects, how the UI changes to reflect the state of the playback. So I loaded a bunch of songs here, which means that, okay, so we are the first song in the queue. It means we cannot go back any further. And instead we can go further down the queue. So we press the play button. Let me. And now the play button changes here to display pause, play here. And it's pretty trivial. Again, I'm not changing the contents of the button in response to the button press event or the clicked signal. Same here. I can skip. Then let's skip to the next song. I'm so sad you cannot hear it because this album is fire. Demon Dice is great. I strongly recommend you find Demon Dice on Bandcamp and then get the album because it's really great. She's amazing. But now that we are at the second track, we can go back here. There you go. And you may have noticed that the reason, so the cover art appears only once we load the song, because the cover art is extracted by GStreamer. If I had access to the cover art from the tag itself, then I would be able to present it instantaneously without having to press play, which is the annoying bit. Honestly, I would actually love to do that. I'll have to figure something out. For instance, I will have to see if somebody has written a tag parsing library crate for Rust that I can use. That is not taglib. Don't know. I'm not entirely enthused about the idea of having to write my own. Oh, Georges. So sweet. Yeah. Oh, I don't know. I don't know if Mario Sanchez Prada told you the good word about the Kendall Mint Cake. He had it in Manchester. He is addicted to it. A mint cake is essentially a block of sugar held together by surface tension, I think, that it is infused with mint extract. Is essentially just that. It's terrifying, but it's great. Lemon bars, I have no idea what a lemon bar is, but probably. Lemon bar is, oh no, it's a shortbread crust and stuff like that. No. This is, let me see if I can get, yeah. Here, it's this. This is a block of sugar. It's literally a block of sugar. There's nothing there. Just sugar. You will die if you eat one of them in less than 5 minutes. You will die. You can coat it with chocolate, but it's terrible. You should never do that. Yeah, it's basically sugar that has been dissolved in water, and then you boil it until the water goes away and it crystallizes into a block. And you put mint extract in it, and it's done. Main ingredients: sugar, glucose, peppermint. Those are not the main ingredients. Those are the only ingredients. Yeah, it's a butter pancake. This is terrifying, and it's incredible. I mean, you eat one of them, and then you can rewrite the Linux kernel in an hour. I will reach sleep past 20. Shockingly, most of them didn't. The people that ate this ate very little and used this in order to go to the factory floor at 4 in the morning and come out of the factory floor at midnight without dying. The people that lived very long didn't eat this. They ate this in very small quantities. Good God. Yeah, it's England in the 1800s. A lot of people didn't live that long. But yeah, if I switch, the content go away. Yeah, again. So this is, again, I would love to have a way to load up the cover art without having to load the file directly in the pipeline. That would be great. I'll have to find it. Also, what's missing is a shuffle button here. So I can shuffle inside the queue. Another thing that's missing is the ability to select an item in the queue and switch to that song. The little room you see here, the little space here, would be used to display the icon of the song that is currently playing in the queue. But other than that, this application is mostly done. At least it's done to the extent to which I'm willing to commit to it in terms of the design. I don't want to write a song music management application. I want to write a music player because I already have all my songs organized, and all I care about is loading a bunch of songs there and then letting it play. That's it. If I want to modify the metadata, I use EasyTag. If I want to modify the structure of my music collection, I change the file system. That's it. I don't care about ratings. I don't care about the lyrics. I don't care about metadata or stuff like I don't want to care about the Wikipedia page of the band. That's it. That's all I care about, is loading up a bunch of songs and then playing them in the background while I work. There are a couple of other things that I should fix, which is mainly the queue here. Right now it's inside a revealer and it's not great. Also, I should have a little bit of a label here that says that tells me the duration of the queue by summing up all the duration of each song, because it's something that Muine had, and Muine is still the best music player that came out of Linux in the past 20 years. So re-implementing Muine is my final goal. And Muine that didn't have any music management like shit. It had a very basic database that essentially just loaded up every single music file you had in a specific directory and then didn't do anything with it. That's it. That's all it did. Georges, no, we eat our desserts. Our desserts are very poor because England was very poor. Most of the desserts are based on bread or like buttery bases, like shortbread, which is basically a stick of butter with flour and egg, and that's it. No, it's not a butter pancake. It's not a stick of butter there. No. I can assure you, they're not sweet at all. It's very basic bread and like gooey, sugary stuff on top. But there's lots of sultanas. So like how's it called? Dried fruit, candied lime, candied lemon, I mean, it's candid because it has to survive the trek from the continental Europe to the UK. Oh, I record. This code language looks incredibly tedious. I wouldn't say it's tedious. I mean, yeah, it can be very verbose. So one of the things that Rust does that is kind of weird in places is it's very explicit in what stuff has to happen and when it has to happen. Like, this would be a very simple in C would be this. It would be a simple cast. It has a type check and it happens at runtime. In this case, it's happening at compile time. It's just a compile time that says whatever happens next, call it on a GTK application. So check that the GTK application, check that what happens next here is actually happening on something that has a GTK application as type. And same thing here is a GTK window cast. So whatever happens next has to be verified to satisfy the GTK window API. That's mostly it. The other stuff that is kind of verbose and weird is like this. In C, this would be something like would be something like this, except the borrow here. The borrow is telling the compiler, hey, I'm just borrowing a simple pointer, so when the variable goes out of scope, do not do anything weird with it, so don't free it. In modern GObject, it would be something like this. It would be something like this. So acquire a reference to the player object. So, and release it when it goes out of scope. So as you can see, it's kind of verbose here. You don't need this in C because it's all pointers. So the pointer would not be freed automatically when it goes out of scope. Yeah, it's kind of like that, but it's verified at compile time, not at runtime, if that makes sense. So it's kind of verbose, but it's verbose for a reason. It's not verbose because of weird rules imposed by the language itself. It's verbose because it's telling you something. And it's not just telling you something, it's telling the compiler something. And telling the compiler something is more important, because then the compiler, when something fails, the compiler will whatever. I mean, it's there. It's in some cases almost like visual noise. I mean, it's not really visual noise because it, again, it's telling you something. But yeah, if you're treating it like, I don't know, Python, where everything is a strong reference, or C, where nothing is a strong reference, then Yeah, it's kind of verbose. Rust tries very much to play both sides, and in doing so, it has a bunch of syntax there that you have to understand. Yeah, you come from C sharp. C sharp is mostly like Python. um, but yeah, it also has the advantage of a garbage collector. So you don't have to deal with a lot of this stuff. The language will deal with that by itself. Again, you can hide a lot of the stuff in theory. You can hide it. Like, for instance, I could have a simple method here that returns a borrowed reference to the player object. I don't, because it's whatever. I still understand it. I still can see what I'm doing. I still can understand what I'm doing. There are some stuff that are like bonkers. There are some things that are bonkers, like the entire fact that I have to wrap around stuff in layers of types to satisfy the compiler that I'm doing the right thing, especially when threads are involved, is kind of really, really bonker. Like here, that I have to essentially create a weak reference to a reference counted data type, and then I need to have a strong reference on the weak reference, so I can then know for a fact that this data will survive for the entire duration of the signal emission that might happen from another thread. It's, yeah, that is kind of bonkers. And that is kind of visual noise. In theory, all of this should go away. So if I did the right thing, if I did the idiomatic thing when it comes to GStreamer usage and different threads, then all of this would go away. I would listen to changes on the message bus, and the message bus then would tell me the stream has ended. And if the stream has ended, then I would send a message across threads, like across thread boundaries, to some other object that it's listening there. And then I would have access to that object without anything specific. And I would then do stuff without having to deal with wrappers around wrappers around wrappers. Still, it's kind of a simple to conceptualize this entire thing, even if you have to deal with this kind of line noise. If you basically just ignore it and say, okay, this is just to satisfy the compiler, it's not doing anything special. But you also have to make sure that what you're doing is safe from a thread perspective. Like, yes, I created this player object here, and I'm telling it, please deliver everything to the main thread, which is the same thread that the GUI is in. Do not deliver messages, do not deliver signals in other threads. Again, this is all runtime, and it has nothing to do with the compile time issues. The compile time API, the API is known at compile time, and the API has to be usable in both cases. The case where everything is dispatched inside the main thread, and everything is dispatched inside whatever thread the player currently resides in. So if you have both cases, the API has to survive both cases, to cover both cases, and one case is more restrictive than the other. But the thing that determines which cases support is currently in use is determined at runtime, and the compiler has to know at compile time. So you have to... it gets frustratingly complicated for, even though you know it's not going to happen. That's the only thing that is kind of annoying. For the rest is, generally speaking, just I have a bunch of native types and I have a bunch of UI elements and I have to bridge the two. And in order to do that, I have to use basic objects that can notify of changes. And I don't want to commit like war crimes with layering violations all over the place. That's mostly it. That's the entire complexity of this thing. It's... I mean, I've seen applications that do it slightly differently. So they create a Rust object that builds all the widgets from UI definition files. And then the player object modifies the widgets. So it has to access the widget themselves. And in doing so, it basically merges the state and the representation of the state inside the same structure, which is perfectly fine. It's not like a huge deal. You can do that. You can do that, and it's fine. Again, it's fine. It's fine. That gets a little bit wonky when you want to modify the state of the widgets of the UI in response to a GStreamer change. In that case, you really, really, really need to notify something else across thread barriers and then have that something else modify the state of the UI. At that point, I mean, I'm doing exactly the same thing without having to deal with separate threads. Though I could. I mean, I could modify the state object here. Instead of having a state object that I directly access from the player here, I could have a channel. So I could have a receiver inside the state object and a sender inside the audio player, and do message passing between the two. So I would not have direct access to the state from here. So this stuff would not exist. It would be message passing. So I would send a message, which is just an enumeration, a union file, a discriminated union type. I would send that across the channel, and then the state object here would receive that message and update itself. That is probably what I will end up doing. That is very likely what I will end up doing. The the overall idea is that it's gonna happen that way. So I will create a channel here inside the player state object, and then I will, when the audio player gets created, I will bind that with a Rust channel. The Rust bindings for glib provide that API for you. That uses the internal API of the main, the glib main context, and that basically is part of the main loop. And it does that automatically for you and deals with locking and blah 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 for you. So it would be a lot easier to deal with. So yeah, the audio player would create like a sender and a receiver pair, and then the state will hold on to the receiver, and then here inside this function, I would, instead of having all of this, I would send a message every time I modify the state. I would probably need another ancillary object somewhere that basically manipulates the state of everything else there, like stop and skip to the next song and whatever else. But yeah, I mean, it requires turning your application out inside out instead of outside in. It requires like modifying the entire thing so that GStreamer is in control and then modifies the UI or modifies the state of the application instead of getting a notification whenever something changes inside GStreamer. It's a kind of a conceptual change. Once I figure out a way to do it without making it suck terribly, I will document it and put it on the GNOME developer documentation website so that people can copy it, can copy the same pattern, because it's something that it's common, I think. Not everyone is a GStreamer hacker. All the GStreamer hackers are very happy about using Rust because it gives you clarity of design and safety when it comes to multi-threaded like behavior, but everyone else doesn't know how to do this because they're used to something that is similar to GTK. It's just, no, there's a single thread that runs, and whenever something changes, I get a notification, and I want to act on that. And I know that happens in a single thread. So yeah, I think it's just a matter of properly documenting with reasonable examples. Otherwise, people will start reading documentation, start reading application code, and applications are complicated. I had to read like 4 or 5 different applications to understand even remotely how to deal with a bunch of this stuff. So it's not entirely trivial, and it speaks to a lack of documentation. Not of every single library. Every single library is properly documented. It's the interaction between different models that is undocumented or severely underdocumented, and that is what fucks people over. Anyway, yeah. I mean, I kind of showed how to deal with this stuff. Let me go back. Right. So I think this is a good place to stop. I mean, I went over the entire code base. There is nothing else. There's nothing else there. Let me see. It's no, not technically. It's less than 2,000 lines of code. And then less than 400 XML lines of XML for the UI definition. So it's a very small application. It's very, very small, aggressively so. I didn't even play golf. I haven't been golfing with this application. I haven't been trying to be clever or anything about the layout of the UI or every single line. I've been exceedingly verbose and plain. If I wanted to golf, I would have done a lot worse. But this application is very small. It's not going to be a large code base. I think it's entirely understandable in probably an hour or two. I would have been able to do this on stream, writing it on stream. Most of the time I spent writing this application was not spent writing code, was spent trying to understand how to do this and reading other people's code and trying to compile it and see where the Rust compiler would start shouting at me, telling me to fix things. Sometimes even telling me how to fix things, which is, you know, nice. Okay. But the overall idea is that this application should be easy to read and understand once it's complete. Right now it's not complete. It's missing a bunch of stuff. I also need to like run the formatting thing, Rust format, and I also need to run Clippy on it, so it identifies like random crappy stuff that I've used. Again, there's nothing really clever in this. There's no like fancy iteration or map reduce like patterns or anything. So, I mean, Clippy can shout at me, but in general, there is nothing that is going to be complicated about this stuff. At least I hope. Yeah, Clippy will probably try to reduce the line length in some places. Yeah, there is nothing really complicated there. So, yeah. Yeah, maybe, I mean, on Monday I will probably start streaming again and just try and fix a bunch of things here, trying to implement functionality like the queue management, the proper queue management. So showing where you currently are in the queue when in the playback, being able to remove single songs from the queue, doing the shuffle, like adding the capability to shuffle the contents of the queue, maybe reflect the shuffle in the queue, which would be an interesting feature. And yeah, hopefully I will also get an icon from somebody. I will bribe somebody to make me an icon that fits in with the rest of GNOME. And after that, I'll publish it on FlatHub, because yeah, I mean, what else is there? Oh, I haven't explained the name. That's what I am. The application is called Amberol. Amberol is, so before records in disk form, there were records on wax cylinders. The wax was not like beeswax. I thought so, and at first when I found out, and I thought about calling this application Honeybee, but no, the wax for wax cylinders was like mineral wax, so was petroleum like something. The main problem at the beginning was that the wax would fall apart after a few playbacks. So the original creators of the wax cylinders for recording invented a new material that it was more plastic for recording, for recordings that were supposed to be played over and over again across any serious amount of time. Well, serious was a couple of decades, not more than that. So they created this new material, and they dyed it blue and called it Blue Amberol, which was also the first recording company called Blue Amberol Records. Thomas Edison was one of the people involved with it. And so I decided to call this application Amberol because of that legacy, like wax cylinders and stuff. So that's the name. That's the reasoning for the name. As usual, naming things is one of the hardest things to do in like computers. So it took me a while to settle down to a specific name, and I chose this. For a while, I thought about resurrecting the name Muine, but I didn't want to step on the toes of the people that made the original Muine, especially since I'm basically changing everything. UI, behavior, language, version of the toolkit. So it wouldn't be a straight port of Muine from C# and Mono to GTK, GTK4. Also because there are no GTK4 bindings for C#, so sadly. Would be nice, but yeah, not a thing. Anyway, I think it is time for me to say bye, everyone. Also for the usual YouTube outro for when I upload the VOD on my YouTube channel. So, right. If you enjoy watching me struggle writing Rust code for the GNOME platform, as well as writing documentation and working on GTK and libadwaita and the core GNOME software development platform, then why not subscribe to my YouTube channel? Otherwise, if you want to watch me struggle live, then you can follow me on Twitch, twitch.tv/Ebasi, and you will get a notification every time I start to stream, which is usually on Monday, Wednesday, and Friday at 4 p.m. London time. For everyone else who's still here, then thank you very much. You have a much higher tolerance to pain being exposed to very bad Rust code from somebody who's basically just doesn't know the language very well, even though I wrote, like, this is the third project I write in Rust. So, but thank you very much for following along. Thank you very much for your questions. Again, always when I stream, feel free to ask as many questions as you like. I don't mind answering questions about GNOME, GTK, and the platform that I contribute to. Have a great rest of your Friday. Have an amazing weekend. Stay safe, everyone. COVID is still a thing. Sadly, I say that with very, very specific knowledge. But other than that, have fun, and I shall see you all on Monday. Bye.